Okay, here we have the daily commuting times for employees. If we look at this example, we here have the frequency distribution of daily one-way commuting time in minutes from home to work for all 25 employees of the company. So first thing here, since it does say all, we are dealing with a population. Okay, and it is grouped data as well. Okay, so we want to find the standard deviation and the variance for this grouped data. So because we are dealing with a population, our formula here is going to be mu for the mean. We have the sum of m times the frequencies over the number of employees. And then our formula for variance is going to be sigma squared, sum of midpoints squared times the frequencies, minus the sum of the midpoints times frequencies squared over n, and then that whole thing over n. And then the standard deviation is going to be the square root of the variance. Okay, so first thing we want to do here, we have the frequencies, okay, and the sum of those frequencies is 25 because it tells us there's 25 employees. We do not have the midpoints though, so we want to find the midpoints. So we do 0 plus 10, that's 10, divided by 2. 10 divided by 2 is going to give us 5. And then we do the same thing for 10 and 20, we get 15. Then we have 25. Then we have 35. And then we have 45. Okay, so we have those. We have our frequencies, which I'm going to write over here so they're even. 4, 9, 6, 4, and 2. We have the sum of our frequencies is 25. We need to find our frequencies squared. Sorry, we need to find our midpoints squared. Here. So we have 15 squared is 225. I skipped the 5 squared. So 25. We have 25 squared is going to be 625. 35 squared is 1,225. And 45 squared is 2,025. Okay, so we have those. So let's first find the mean. Okay, so we'll find MF. Okay, so MF is midpoint times the frequency. So we have here 5 times 4, 20. 15 times 9, 135. 25 times 6, 150. 35 times 4 is going to give us 140. And 45 times 2 is going to give us 90. So the sum of those, we have 20 plus 135 plus 150 plus 140 plus 90. That's going to give us 535. Okay, so the sum of our midpoint and frequencies is 535. And the population is 25. So 535 divided by 25 is going to give us a mean of 21.4. Okay, now we're going to find our variance. So we have the sum of our midpoint squared times our frequencies. Okay, so we need to find that. So midpoint squared times our frequencies. Okay, so our midpoint squared is 25 times our frequency of 4 is 100. Then we're going to do 225 times 9. That's going to give us 2,025. Then we have 625 times 6, which gives us 3,750. Then we have 1,225 times 4. We have 4,900. And we have 2025 times 2, going to give us 4050. Okay, so the sum of that is going to be 100 plus 2025 plus 3750 plus 4900 plus 4050. So 14,825. Okay, so we have everything we need here. We have, let's see here, so we're going to do our formula. We have the sum of midpoint squared times the frequency, so 14,825, minus the sum of midpoint times frequency, which was here, this 535. Then we're going to square that and put it over 25 for our n, and that whole thing is going to be over 25. So I'm just going to pull up this calculator here so we can do this problem. So we have, turn this on, we have 14,825. Actually, you know what? Let's do 535 squared first. We have 535 squared. Then we're going to divide that by 25. And then we're going to do 14,825, subtract that value, so minus second answer. And then we're going to divide that by 25. And that's going to give us 135.04. So that is our variance. And now we want to find our standard deviation. So now we're just going to take the square root of 135.04. Variance is sigma squared. So sigma is going to be our standard deviation. So we will go here and go to second square root, second answer, and we get 11.62. So we have a mean of 21.4, a variance of 135.04, and a standard deviation of 11.62.